All right, we're doing our third homework here for probability, talking about conditional probability. And this was in a couple of the other homeworks. So the first section and second section didn't have its own dedicated homework. What's the probability of choosing someone who isn't in French? So the probability of the complement of French, given that the person is in Spanish. So in this scenario, we want to choose someone who is in Spanish, but they're not in French. So someone that's in Spanish, but the complement of French, which means they're not in French. So that would be 5 people out of a total of 12. There's 12 that are in Spanish, given that it's in Spanish. What's the chances that they're not in French? That would be the 5 here out of 12. The next question, what's the probability of choosing a person who did not take Spanish? So the probability that the person is not in Spanish, given that the person is in French class. So we only look at the French people. There are 19 of those. Of those 19, which one did not take Spanish? That would be 12 of the 17, or of the 19. Lovely. Concussed boogers. Let me just copy this down so I can see it easily. So find the probability of someone, let me read the scenario again. Oh yeah, concussions and picking their nose. What's the probability that someone has a concussion given that they pick their nose? So here are the pickers. There are 15 people in their total, so that's the subset we're using. Of those 15, how many had a concussion? Just 8. Find the probability that someone picks their nose given they had a concussion. So we're going to subset of people that had concussions. There are 10 people. Of the 10 that had a concussion, how many are pickers? Well, 8 of the 10. Reduce it if you want, you don't need to. What's the probability that someone is a picker given that they had the complement of a concussion? So the complement of a concussion means they didn't have a concussion. So everyone in here had a concussion. People that didn't have a concussion would be these people here, the 7 and the 5. There are 12 people that had never had a concussion. Of those 12 that never had a concussion, how many are pickers? Only 7. So it's 7 out of 12. Then the final one, what's the probability that someone had a concussion given that they were not pickers? So everyone in here is a picker. The not pickers would be the 5 and the 2. Not pickers is 5 and 2. That's 7 people total. Of the not pickers, how many of those have had a concussion? Just 2 out of the 7. A couple more here on the back. Let me copy these pictures down once again so I can easily see them. And I used an N here instead of an S for Switch. I used an N for Nintendo, but we'll get to that in a second. What's the probability that someone, what's W and P stand for? Watermelon and popsicle. Still think popsicle spelled wrong. What's the probability that someone ate a watermelon given that we know they ate a popsicle? Here's all the people that had popsicles. There were 11 of those. Of those 11, 5 had popsicle, or 5 had watermelon. That's 5 out of 11. Almost a half. What's the probability that someone had a popsicle given that they had watermelon? So how many people had watermelon? That's 9. Of those 9, 5 had a popsicle. This is Xbox and Nintendo Switch, this next one. What's the probability that someone has an Xbox given that they don't have a Nintendo Switch? So the people that don't have a Nintendo Switch will be people outside the Switch circle. That's 10 and 40, that's 50. we have 50 to choose from. Of the 50 to choose from, how many of those have an Xbox? That would be 10. 1 out of 5. What's the probability that someone doesn't have a Nintendo given that they don't have an Xbox? All right, so the people that don't have an Xbox would be 40 plus 35, that's 75. And then the people that don't have a Switch, out of those 75, well, that's 40 people. It's 40 out of 75. Oh, we got more. Just when we thought we were done. D and P. D is dog. P is paradoxosaur. And over here, C stands for computer. A stands for art. All right. What's the probability that someone, tell you what, let's read this backwards because I think it actually makes more sense. Given that someone walked a paradoxosaur, there are 25 of those people. What's the chances that that person walked a dog, is a dog walker? Well, there are 25 people that have walked a paradoxosaur. Of those 25, 15 have also walked the dog. Given that a person didn't walk a dog, so the non-dog walkers would be the 10 and the 20, which is 30. How many of those that didn't walk a dog walked a paradoxosaur? Well, that would be 10 out of 30. Reduce it if you want. Over yonder, we got computer class, art class. Given that someone took a computer class, that would be 22 people, 7 and 15. What's the probability that the person didn't take art? So that's what this means, complement of art. That would be 7. 7 out of 22. Given that someone's in art, that's 15 and 15, that's 30 people. What's the chances the person did not take computer class? Well, here's the ones that didn't take computer that are in art. That's 15 out of 30. That's a half. If we skip ahead to P2's homework, we added some questions here from the notes. Given that someone got a complement of a 1 the first time, that's here, what's the chances they got a complement of a 1 on their second pick? Well, if you remember, you may not, we're rolling die. Chances of getting a 1 is 1 out of 6. The chances of not getting a 1 is 5 out of 6. These are independent events. So it doesn't matter how we get to this point. Once we're there, what's the chances we don't get a 1? Well, that's 5 out of 6. Given that a person got a 1 the first time, that's this path. Once again, we don't care about the probability of getting there. What's the chances they get a 1 the second time? That is 1 out of 6. Independent events. So if it's independent, this condition doesn't matter. It has no effect on the answer. So this is the same as just me saying, what's the probability of getting not a 1? What's the probability of getting a 1? Because the condition doesn't matter if they're independent events. These are dependent, the condition definitely matters. Given that a person got a red on their first card, what's the chances their next card is a red? So we're looking at this probability only because we don't care how we got there. That's 25 out of 51. Notice how that's different than the original red that we got because they're dependent events. What's the probability, given that someone didn't get a red, that their next card is also not a red? So once again, we don't care about this number. We just get to this point. And then the fact that they didn't get a red the second time was 25 out of 51. Something doesn't feel, oh yeah, that's right. I was going to say something doesn't feel right about that. That's because there's just red and black cards, equal chance. Oh, I skipped this little fella. These are independent events, which means you could ignore this conditional if you want. You're going to get the same answer. Given that someone got a heart, what's the chances that the next card was a heart? Well, it's 13 out of 52. Notice that's a different question than asking what's the probability that someone gets 2 hearts in a row. This is saying what's the chance that their second card's a heart given that their first card is a heart. What's the chances that the first card wasn't a heart? No, I'm sorry. Given that the first card wasn't a heart, what's the chances the second card wasn't a heart? So given that it wasn't a heart, chances that the second one wasn't a heart is also 39 out of 52. I say also because that was the chance of the first one. Because if they're independent events, those probabilities never change. See, I gave you just 2 more to do. Skip any other ones? 2 more to do. Given that we didn't get a face card, so that's this path, what's the chances that we get a face card? These are dependent events, so that's 12 out of 51. Notice how that's different than the first getting a face card. Given that we got a face card the first time, so now we're here, what's the chances the next card is not a face card? That's 40 out of 51. Dependent events, that's different than the original not getting a face card. All right, that wraps her up.